Deep in the darkness between galaxies, something extraordinary is happening. For centuries, black holes have represented some of the most destructive objects known to science. Their gravity can become so powerful that once matter crosses the event horizon, even light cannot escape. But what if a black hole were not simply sitting at the center of a galaxy? What if it were moving? Astronomers have been studying evidence of a massive black hole traveling rapidly through space, creating a phenomenon that looks dramatically different from the traditional image of a black hole quietly consuming material at the heart of a galaxy. The object is believed to be moving at millions of miles per hour. That speed is difficult to imagine. Yet the most fascinating part may not be the black hole itself. Behind it appears to be a long, luminous structure associated with young stars. Instead of leaving behind only destruction, the moving object may be influencing its surroundings in a way that encourages new stars to form. That possibility completely changes how we think about the event. The James Webb Space Telescope is especially valuable for investigating such distant phenomena because it observes infrared light. Infrared wavelengths can reveal structures hidden behind enormous quantities of dust and gas that are difficult to study using visible light. When astronomers examine distant galaxies and unusual objects through Webb, they are effectively looking into the past. The light reaching the telescope may have traveled for millions or billions of years before arriving at its mirrors. That means every observation is a glimpse into an earlier stage of cosmic history. In the case of the runaway black hole, researchers are interested in what happens to the material surrounding its path. A black hole moving through a galaxy can interact with gas and dust along the way. Its gravitational influence may disturb surrounding material, while shock waves could compress clouds of gas. Under the right conditions, compressed gas can collapse under gravity. And when enough material gathers together, a new star can begin forming. This creates an extraordinary possibility. A black hole normally makes us think of something consuming matter. But its movement through a dense environment could potentially create conditions that help trigger star formation behind it. The resulting trail may extend across an enormous distance, far larger than anything we encounter in our everyday experience. Imagine a structure tens or hundreds of thousands of light-years long. A single light-year is already an almost incomprehensible distance. The amount of space light travels in 1 year. Now multiply that by thousands. Then imagine a luminous trail stretching behind a massive object as it moves through a galaxy. That is the scale of the phenomenon scientists are trying to understand. However, there is an important distinction between observing a striking structure and understanding exactly what caused it. Astronomy often begins with an unexpected pattern. Scientists then test multiple explanations. A glowing trail could contain newly formed stars, heated gas, shock fronts, or a combination of different processes. The challenge is determining which explanation fits all of the available evidence. If the stars in the trail truly formed because of the black hole's passage, the discovery would reveal an unusual connection between destruction and creation. It would demonstrate that the universe does not always divide cosmic objects into simple categories. Black holes can be destructive, but their gravitational effects can also reshape their environments. Gas clouds can collapse into stars. Stars eventually die. Their remains return elements to surrounding space. Those elements can later become part of new stars, planets, and other objects. The universe is constantly recycling matter. And this strange runaway black hole may be giving astronomers another glimpse into that enormous cycle. But this is only one side of the story. Because while scientists investigate this extraordinary moving object, Webb has also been observing another cosmic environment where destruction and creation are happening on a completely different scale. A galaxy collision. And one of the most spectacular examples is ARP 220. If the runaway black hole shows how one object can reshape its surroundings, ARP 220 demonstrates what can happen when entire galaxies collide. Located roughly hundreds of millions of light-years away, ARP 220 is an extraordinary infrared bright galaxy. It is not a normal spiral galaxy peacefully evolving in isolation. Instead, it is the product of a gigantic merger between two galaxies. Long ago, two enormous galaxies began approaching one another. Their gravitational attraction slowly pulled them together. At first, the interaction would have been subtle. But as the galaxies came closer, their gravity began disturbing their structures. Spiral arms became stretched. Stars were pushed into new trajectories. Huge clouds of gas and dust collided. Eventually, the two galaxies began merging into one enormous and highly active system. The collision triggered an intense period of star formation. This is one of the reasons ARP 220 is so scientifically interesting. When galaxies collide, their gas can become compressed. That compression can create the conditions needed for enormous numbers of stars to form over relatively short astronomical timescales. Webb's infrared capabilities are particularly useful here. Visible light struggles to pass through thick clouds of cosmic dust. Infrared radiation, however, can reveal structures hidden within these dusty regions. As a result, astronomers can investigate activity that would otherwise remain obscured. Inside ARP 220, researchers can study dense regions containing young stars and enormous amounts of heated material. The galaxy becomes a kind of natural laboratory for observing how galactic collisions transform matter. But there is another important part of this story. Massive stars do not live forever. Some survive for millions of years before ending their lives in tremendous stellar explosions known as supernovae. These explosions distribute heavy elements into surrounding space. Elements such as oxygen, carbon, calcium, and iron are produced or dispersed through generations of stellar activity. Eventually, some of that material can become part of planets and other cosmic objects. In other words, even stellar destruction contributes to future creation. ARP 220 therefore represents much more than a spectacular image. It is evidence of a galaxy undergoing a dramatic transformation. Two galaxies once existed separately. Gravity brought them together. Their collision reshaped their structures. Gas was compressed. New stars were born. Massive stars later exploded. And the material released by those explosions became part of the continuing cycle of cosmic evolution. This brings the story back to the mysterious runaway black hole. At first glance, the two discoveries seem completely unrelated. One involves a massive object moving rapidly through space. The other involves two galaxies merging together. But both demonstrate the same fundamental principle. The universe is constantly changing. Objects that appear destructive can sometimes create the conditions for new structures. Violent events can trigger star formation. Stars can die while simultaneously providing the raw ingredients for future generations. Galaxies can be torn apart and then become something entirely new. That is why observations from the James Webb Space Telescope are so valuable. Webb is not merely producing beautiful photographs. Its observations allow scientists to examine processes occurring across enormous distances and over immense periods of time. Every distant object contains information about the history of the universe. The runaway black hole offers a glimpse into how gravitational forces can reshape the material around them. ARP 220 shows how galactic collisions can transform entire stellar systems. Together, they reveal a universe that is anything but static. There is no simple boundary between destruction and creation. Instead, the two are often connected. A star is born from material left behind by earlier generations. A galaxy changes because gravity rearranges its contents. A dying star releases elements that may eventually become part of another world. And even the most violent events can contribute to the next stage of cosmic evolution. Webb continues to observe these distant environments, collecting ancient light that has traveled across space for millions or billions of years. With every new observation, another piece of the cosmic puzzle becomes visible. And perhaps that is the most remarkable discovery of all. The universe is not simply destroying and creating objects at random. It is constantly transforming. What looks like an ending from one perspective may actually be the beginning of something else. And somewhere in the darkness, the next extraordinary transformation is already taking place.